Hello Internet, welcome back to our shield shader. In this video we're going to be doing something a little bit different. We are going to be making the probably most expensive way to do nothing in a shader. And so we're going to be looking at grab passes. What a grab pass is it is a pass in your graphics pipeline, effectively a second pass that is going to grab the screen texture or going to grab the render. So if you want to do, say, refraction, you would render the rest of the scene, and then you would save that to a texture, and that will be your grab pass. You will grab the contents of the screen, and then you will render your new refracted texture on top of that, using however you want to do it. We're going to do that, and it's just going to be a super simple way to just kind of demonstrate how to get that integrated into a surface shader. At least I hope. Unity's documentation does a fragment vertex shader. We're going to try to do it with a surface shader, and hopefully it just goes super smoothly. I've never done this, so we're gonna find out. So first things first, we're gonna attempt to right click, and everything's gonna freeze. This is a good start. I don't know what that was, but we'll ignore that and pretend like that's part of the plan. And we will just call this a refraction shader. It's not really, this part is not really going to handle refraction, but we can make it. And so that will extend this. We'll add some feature creep to this. We'll make this actually support that, I guess. And we'll see what happens. We'll make it so you can actually shift the UVs and refract things through this. So this is default surface shader. What we need to do is, before our first pass, we need to add a new pass. Let's see here. What's the best way to do this? Let's do it here, I think. Do we need, okay. So I think we can get away. Grab pass may be special. And so I think we can actually just get away with creating this by itself. So we're going to call this the refraction texture. No, we'll just call this the grab texture. You actually don't need to name this. Unity has a default one. I think it's actually grab texture, but I'm going to give it a name just because I think that's nice. And that way, if we ever need to change it, it's more obvious that we're changing it instead of adding something new. So we'll add the grab texture, and everything else can just kind of stick around. I think we can take out this instancing code. I don't think we want to keep that there, because I think that might break a few things. So that's going away. And then for our input, we actually need some UVs. So we're not going to pass in our main texture because that is the texture of the object we're rendering. That's going to be related to the model. What we need instead is sort of a UV grab texture. And so this is going to be the UV for our grab space. So it's actually going to be in screen space where the texel or the texel you're drawing is. So that's how that's going to work. Then we need a vertex shader. The vertex shader is actually going to calculate the position. And so the reason you use a vertex shader here is because it's just going to be way easier. The vertex shader is actually going to get the positions of the vertices and things like that, which we can then extrapolate out and actually solve this. We could do it in the surface shader itself. And I think we already do that for the shield. But I don't... Should we do that? Could we do that? We could do that. Let's see what happens. Let's just try that. I don't know. If it doesn't work, it doesn't work. So let's grab this. We're definitely going to need our world position. So this needs to be a float 3 of the world position. Pass that in. And then this will get us our object space position. And then once we have that, we need a UV grab texture. Yeah. So we're gonna probably take this out of the input. And then we should be able to just do compute grab screen pose. Position? I think it's just pose. And so the way this is going to work, when you compute the grab screen position, it's going to effectively take the position, the object space position, and calculate where on the screen that is. And then based on that, we know where to look up. If it's in the center, your UV should be 0.5, 0.5, because it's in the center. And so that's how that works. So if we plug in our object position, theoretically that works. No idea. We don't really have IntelliSense, so we won't know yet. And then we need to actually pull out the grab texture from here. And so this is going to be a projection. Yes. Yeah, so this part is coming straight from another example that I will link in the description. But I believe we need to use the text 2D projection, or the projected 2D texture, because this is going to be a thing. Yes, that was a very good way to describe that. That definitely helped people and made it very easy to understand. No, this is going to be projecting the... What am I trying? What's the word I'm looking for? It's not using just 2D coordinates. You know, I don't think I need to do anything more than that. I think that kind of says what I wanted to say. But yeah, it's not using two-dimensional coordinates, it's using these. So it's actually projecting, I think it's actually 4D, but we'll find out. If this is wrong, we'll probably get super interesting results, which isn't always a bad thing. So this should be everything we need. We're now reading from our grab texture instead of the main texture. We're actually not using the main texture at all. We're trying to do our object position, calculating that, getting a grab texture, doing everything else fun, and it's super broke. That's nice. Compute grab screen position. Do you like float force? Because I can give you float force. Incompatible types and initialization. Okay. It may not approve. Actually, that would probably solve it, wouldn't it? So this multiplication is going to return a four-dimensional, a 4-point float. So there's going to be 4 arguments there, x, y, z, and v. And so we were just filtering it down to the 3, x, y, and z. We need that 4th one to still be there because we're going to pass that in to our grab screen position. That should work-ish. And so what I should be able to do is create a new material. We'll call it the Refracted. And so if I attach this shader to it, and then attach this to the sphere, ooh, it's not right, but it's not quite wrong either. I think we're upside down. It looks like we're upside down. Yeah, so can we just flip that? We might be able to just flip that. This seems like a really bad idea. Am I going to regret this? Probably. So we're going to multiply the Y part of the UV by -1. That should flip. That didn't flip it. Ah. Can't say I know why it's upside down. That's kind of annoying. On the bright side, it does appear to work. It just upside down, and also maybe not in the right spot. Yeah. So I'm thinking the vertex bit may have been a or not skipping the vertex part may have been a mistake. Because there's our world and there's our skybox. But that's not how that's supposed to work. Yeah. Let's go back to that, not that. Let's go and try to just do this the sane way. We have this UV grab texture. Let's solve for this bit inside of a vertex shader. And so what we can do is just create a void vert, and then the input is going to be in out of the app data. We'll use the full app data. There's a few varieties of app data. App data full is going to have just more things. And so that, I guess, I don't really know the best time to use each of them. Usually when I'm developing something, it tends to just go with full. I don't know, getting distracted, but that's sort of how that goes. We'll do an input of that with the out of our input, which is probably, that's kind of confusing. But the way this is working, this input is coming from our triangles. This is our mesh data that's coming in. The output is stuff that we're feeding to the surface shader. This stuff. And so we need to calculate this grab texture before we return. If we don't, it's not, the surface shader is not going to get the right thing, and then it's going to freak out and everybody's going to be sad. So we're gonna try to make this happy, and then it won't break on us. I didn't want to delete that yet. Let's see here. I think we can just pull this stuff up. So that moves up there. And then the only thing we need to change is this input world position. We don't need that. That can become a input dot vertex. I think that's the, yeah, that should be the vertex point for each vertex we're rendering. That should be in object space. No. Is it? Oh no. I don't know what space that's in. I should know that. That should be in, I want to say object space, but I don't think that's correct. Well, we're gonna find out. And I think we need to flip this too, which might have been why we were getting that weird issue before, is because we actually went the wrong direction. We want this to be a object to world. Now Unity's documentation uses the MVP matrix. They use Unity matrix MVP. I think this is the new version. We're gonna find out real quick. So this is our world position now. So we're gonna compute the grab screen position for that, and then pass that back as the UV grab texture to our output. So O.UV grab texture. That should get it into our surface shader, which then should be able to use it. Or break. That's nice. This is supposed to be a float 4. Fixed it. And now it's purple. We went from white to purple. This is not a good start. From const float 2 to float 4. Okay, what's trying to do that? Oh. We probably want to say that there's a vertex shader. Might be a good idea. Might solve part of the problem. I don't know if that's the problem, but that's part of the problem. Where is it doing this? I have done something silly here. And I'm going to find out what it is, and then I'm going to be really annoyed. But I don't know what it is, and I'm really annoyed. Let's see if Unity updates this. We'll go to what Unity has in their docs. Should have been updated. Object to clip position. That's a different thing than what I was expecting, but we can accept that. Still need to figure out why this is happening. Well, this is interesting. I guess I need to explore this a little bit. One sec. Let me see what's going on here. I think I'm missing something obvious. But I don't know what it is. Unless it's like something silly like full forward shadows being on. Which, okay, good. That would have been very odd. Yeah, let me dig into this and see what's going on, because I don't know, and it's confusing. So I will be back once I have this hurdle sorted out. All right, it works now, and the error was really stupid. So what I had done is, if you remember, we had this fun little thing called the UV grab texture. Problem is, Unity automatically, when you add a sampler, if you do UV underscore whatever the texture name is, or UV the texture name, it's gonna be smart and create one for you that automatically is based on the UVs of your stuff. That's a surface shader thing. And so when I did that and used that name, what ended up happening is Unity was like, here you go. Here is your UVs. And they were wrong. They were a float 2 instead of a float 4, which we were using because we're using a float 4 for these projection thingy-majigs. And so that totally blew up everything, and then that didn't work. But now, if we add this back, it does work. Since this is a surface shader and not just a vertex and fragment shader, we are actually going to get some lighting on this. So it's not a like complete transparency, which makes it slightly less useless. It's just a really, expensive grass. Oh, I turned off the albedo. That would be why. So here is sort of the end result. And as you can see, it's literally just the same thing. And so I told you we were going to add some refraction to this. So let's do that. Let's add some really basic refraction. And so we'll do float for refract. Is this a good idea? This might be a really bad idea. But I think we should be able to do refract equals I.normal times the refract amount. And so this is going to refract it based on the normal. We probably want this to be in screen space. So let's try this. Unity object to clip pose. Like that. Is that going to work? That might not work. We'll see. Don't know what I'm doing. Well, actually, let's just keep it at normal for now, and we can play with this a lot. We will probably be adding it anyway. So What this means is we need a refraction amount. Fraction amount. And let's give it a range. That's not right. There we go. Let's actually just do a float. And that way we can make it negative if we want, or positive, or play around with the values as much as we feel like. So we're going to do 0.1. This is going to actually move those UVs. And so this could actually have, it's going to be very sensitive. This is going to be very small numbers we're going to be working with, like very small numbers, because 1 would literally shift it over a screen size, which might be a bit much. So we're gonna try to avoid that. And we'll call it the refract amount. Refraction amount actually is a better name. We'll use that. Cool. Float, do that. Done. Now we don't use this at all. And so what we need to do is add it. I think this is probably the worst way to do this. This is going to get us wrong results, but it shouldn't break. It broke. Well, we tried. Let's see, we have the grab UV plus the refraction. Refact. We should probably get our names right. That's been a big pain for this particular thing. The normal. Assignment of incompatible types. The normal is going to be a float 3. So let's make this a float 4. And the final component will just be 0. I think that should be fine. Also, we probably want it to go into the input instead of just into something that doesn't actually exist. Also a good choice. Done. So now you can see it's just slightly below. Like if you look at the brown of the ground, it's slightly below. But if we crank this up to say 0.25, it goes even further away. And so what happens if I put a cube behind it? We don't see a cube because my draw calls are all messed up. Welp, that was supposed to work differently. Why isn't it rendering back to front? It was a good idea. The execution needs work. Why is it doing it this way? Oh, I know why. We want this to be in a different render queue. Let me check quick how to do that. Got it. Sorry, I always forget these tags. I always get them wrong. We want this to be transparent. And so the important thing when you set something to be transparent, it's going to be back to front. And that's to prevent things from just destroying other things. Ooh. Oh, we've made a magnifying glass. Nice. So there is our cube. It is getting pulled out because all of the image is getting pulled out with the rest of everything. So that's why it's round. Ooh. Okay, if I get a little bit closer. There we go. Let's make you a bit bigger. That will make this way easier. But anyway, if I move towards the cube, it goes that way. Why does it go that way? Because normals. Normals are fun. So let's mess with this a little bit. We can kind of pull it or shrink things. So obviously once we get this small, where most of it is just going to be repeating, it's going to actually hit the end of the skybox and just kind of repeat that same image, but we're kind of doing that thing. So Yeah, there you go. There is a cube that is getting magnified. I guess it's a magnification by this using a grab pass. This isn't the correct way to really do this in most cases. I wouldn't recommend doing this if you need to magnify something. There's better ways. You can mess with depth of field. But for other things, it works quite well. Like if we had a complex object, like say something that wasn't a sphere, using the same effect, we would have more complicated refraction, which would be actually quite interesting. So I don't know. This is interesting. It's an interesting tool, especially for just how easy it is. The grab pass is not a hard thing to do. We kind of took it in a weird direction, and that didn't really turn out as well as I'd hoped, but we got there in the end. So if you need to add refraction, this is how you do it. If you guys have any other things that you want to experiment with or learn more about, let me know in the comments, and I would be glad to look into them if they're interesting. If there's any feedback for me, any suggestions you have, let me know in the comments below, and I will take a look. Other than that, I will see you guys in the next video. So until then, see you, Internet.